Did you know that where you grow up could significantly impact your risk of developing multiple sclerosis? In this video, we step away from individual cellular pathology and look at the bigger picture, the global map of neurodegenerative disease. Using the historical data from the Global Burden of Disease study featured in this image, we break down the worldwide distribution and prevalence of multiple sclerosis. Whether you are a medical student or studying public health, a clinician analyzing the epidemiology, or a science enthusiast curious about environmental triggers, this deep dive explores the fascinating pattern behind where multiple sclerosis strikes hardest around the globe. The data map immediately highlights a well known medical phenomenon called the latitude gradient, where multiple sclerosis prevalence heavily increases the further you move away from the equator. If you look at the northernmost regions of the image, you will see territories like Greenland shaded in deep red, indicating a massive prevalence of 270 to 300 cases per 1 lakh population. Similarly, parts of North America and Europe show high golden shade concentrations. In stark contrast, a thick band of deep blue sweeps directly across the equator, covering most of the Africa, Latin America, Southeast Asia, revealing areas where multiple sclerosis remains incredibly rare, with fewer than 30 cases per lakh population. What explains these massive geographical disparities? Scientists and epidemiologists point to a mix of environmental and genetic triggers, with the leading theory revolving around sunlight exposure and vitamin D production, which naturally acts as an immune system regulator. However, the insects at the bottom of the map shows a complex regional data in smaller island nations and territories like Caribbean and Balkan Peninsula, proving that local genetic clusters and regional lifestyles play a massive role alongside the geography. Understanding this global map is a critical step towards unlocking what triggers the multiple sclerosis and how we might one day prevent it entirely.